So, problem 4 from the pre-calc test asks us, according to car and driver, an Alfa Romeo, I've drawn it here, has, at a speed of 80 miles per hour, or a velocity of 80 miles per hour, that's v for velocity, requires 160 feet, that's the distance required to stop. Assuming that the stopping distance is proportional to the square of the velocity, find the stopping distance required by an Alfa Romeo going at 30 miles per hour. Well, their description of the relationship between distance and velocity is a little bit of a mouthful, so let's take that down, take that piece by piece. The stopping distance, d, is proportional. That means it's equal to something related to the square of the velocity. So something related to, we're going to let this k be a constant that represents the proportion between distance and the square of the velocity. That's what they're really saying when they say that stopping distance is proportional to the square of the velocity. And then they want us to find the stopping distance required by this car going at 30 miles an hour. So first, we have to figure out what this relational constant is. And we have enough information to find that out as it is. We can plug in our initial velocity and distance relationship. K has to be equal to the distance divided by the stopping distance divided by the velocity squared. And we already have a distance and a velocity squared that we can use. We have 160 feet as our distance divided by 80 miles per hour squared. So, if we solve this through, k is equal to 16 divided by 160 divided by 6400. It's quite a number. I don't really feel like figuring out what that is in real time, so we're just going to use this as our k. Now, if we want to solve how much distance it takes to stop when the car is going 30 miles an hour, that's going to be 160 feet over 6400 miles per hour squared times 30 miles per hour squared. Then just notice that our units will cancel out, so we'll be left with feet as our distance. And the answer is, in fact, that the stopping distance when you're going 30 miles an hour is equal to 160 times 30 squared all over 6400 squared feet. Now, you can either plug that into WebWorks directly, or you can use a calculator to find an approximation and plug that in with at least 3 decimal places of accuracy.